Welcome to the first part of Competency 11 quiz questions. In this video, we will answer questions relating to geometry and measurement. Number 1. In a right triangle, the length of the hypotenuse is twice that of the smaller leg. If the other leg is 15, how many inches is the hypotenuse? Okay, so what are we looking for? Let's draw a quick triangle. So we have the hypotenuse is 2x, smaller one is x, and then the other one is 15. So let's set up our Pythagorean theorem because I said it is a right triangle. So this means that we have 2x squared equals x squared plus 15 squared. Okay, now I know that I can already see what we're going to do, but let's go ahead and rewrite. We have 2 times 2 is 4. Oh, actually, I need to clean this up. That is not exactly the way to do that. We need parentheses and then squared. We're squaring the entire thing. 2 times x, okay? All right, so that makes 2 times 2 is 4, and then we have an x squared, and then equals the x squared plus the 15 squared. So this means now we are subtracting x squared from both sides. So this would be minus 1x squared, okay? So what do we end up with? This cancels, and then 4 minus 1 is 3x squared, and then we have 15 squared on this side. Now, we divide both sides by the 3, so 3 over 3 is 1. Now, this becomes, I'm going to come over here, okay? If we want x on its own, we need to put under the radical the 15 squared over 3. So let's put that in the calculator and see what happens. So second radical 15, square it, divide by 3, push enter. Do we have a solution? What did the question say? It said, how many inches is the hypotenuse? So we're looking for 2 times x. We only have the value of x. So we have to get over here in our calculator and just say times 2 and push enter, which would be option D. Now, another thing that you need to make sure that you're aware of is looking at the lengths, respectively, and always ask yourself if you have a situation where you have X and then anything, X is something you're searching for. There's a missing piece, and then another piece says 5 times greater, or 2 units more, or 7 units more. Make sure that you go back to your question and look at it and say, well, do they just want this missing piece? Or do they want the piece that says 7 plus the missing piece? Okay, that's one reason why it clicked in my head. I said, wait a minute. I'm looking at my picture that I drew, and I actually technically have 2 missing pieces. Okay, well, they might ask me for both. Who knows? Anyway, number 2. All right. A parallelogram and a rhombus have equal perimeters. Each side of the rhombus is 16. If the length of the parallelogram is 21 units, what is the width? Okay, let's just quickly draw that out. Okay, I have a parallelogram, and we have 21, and a width, and a width. That is all supposed to equal my rhombus. And the property of a rhombus is congruent sides. The diagonals are not congruent, but the sides are. And they are all 16. So let's write that out. What do we really have? We just have an algebraic situation. So we have 2w plus 2 21s equals 4 16s. Okay? All right, so now I will subtract 2 times 21 from both sides. Subtract 2 times, 21. Okay, this cancels. Okay, now I'll go ahead and rewrite this whole thing because I want you to see how we're going to put this in the calculator. Okay, so we will have 2w equals 4 times 16 minus 2 times 21. Divide by 2 on both sides. Now, this is what we need to put in the calculator, okay? So in parentheses, 4 times 16 minus 2 times 21. Close our parentheses. Divide by 2. Okay, and press enter. And that gives us 11, which is the correct option. Okay, and I changed that to put in my calculator because I was concerned about the order of operations. Okay, all right, and that just solved my issue. All right, so number 3 says, what is the area of a triangle whose sides of length with sides of length 7, 14, and 17? That screams Heron's formula. Okay, all right, so first we need S. S equals, and then we have 7 plus 14 plus 17 divided by 2. So our S equals what? All right, so we need to use, you got to use our parentheses around the numerator because we are quote unquote mixing addition and division. So we'll say they're a different level of operation. Okay, so 2. So 7 plus 14 plus 17. Close my parentheses, and I'll divide by 2, and that is 19. Okay, for herons, what do we have? We have the area equals everything under the square root. Okay, well, I went a little bit far with that. You know what? We'll solve that issue by just drawing a line to separate our word. Okay, so that gives us 19 in parentheses, 19 minus the 7, and then again in parentheses, 19 minus the 14, and again 19 minus the, should be 17, not 7. There we go. 17, and we just put that in the calculator. See what happens. Okay. Second, get your radical, 19. Open my parentheses, 19 minus 7. Close my parentheses, open them up again. 19 minus 14, close them, open parentheses, 19 minus 17, and close. Double check, make sure I have 19 and 7, then 14, then 17, and push enter. And that would be the correct option. Okay, great. Oh, if you didn't remember everything about Heron's formula, we did have this in other videos. And also, I have some suggestions of places to go at the end of each of my videos, resources. And there's a primary YouTube uh, resource that's really my preferred person, a really great person, really great work. You might want to try looking at the end and jotting that down or Googling my suggestion. Okay. All right. Let's go to number 4. Number 4. In triangle JKL, J equals 8 and KL equals 18. And the measure of angle K equals 40 degrees. What is the area of triangle JKL. Okay. Because of the way they've done the notation, I know that we have side, angle, side. Well, how do I know this? Okay, well, first off, this angle K here, it's in the middle, okay? And then I see that we have a leg from J to K, and then from K to L is the measure of the other leg. So what we have is the side measure, the angle, side measure. So I know that without drawing it. You can draw it if it makes you feel comfortable. But I just realized that from the notation. Okay, so they want area. Because I have side, angle, side, I know that the area, the law of sine applied to area will work. Okay, so I know that's what I need. So I have area equals 8 times 18. Divide that by 2. Sine of 40. Let's pop that in the calculator. 8 times 18. Divide by 2. Sine of 40. Close my parentheses. Push enter, and I do have a correct option. Okay. All right, let's look at number 5. I know that just seems so much harder than it really was, right? Okay, number 5. The area of a rhombus is twice the area of a rectangle. The diagonals of the rhombus are 10 and 16. Let's go with this twice right here. If the width of the rectangle is, oh, that's it, the width. Okay, 3.2 centimeters. What is the rectangle's length? Let's draw this real quick, okay? So we have a rectangle, right? And it says a rectangle. And then it will equal a rhombus. Okay. Now, for a rhombus, okay, the diagonals. Okay, the diagonals of a rhombus. Okay. So we have our diagonals like this, but our width is 3.2. Okay, I see it now. All right. So what do we need to do? We need to say that the rhombus is, that area is twice the area of the rectangle. And that rectangle is 3.2, right? And we know the area is base times height, right? So we don't know the base. Or rather, in this case, they're calling it length. So let's get rid of this and call it length. Okay? All right, yeah, what is the length? Okay, so we're just going to call that L. And that equals, now the area of a rhombus is diagonal 1 times diagonal 2, all divided by 2. Okay, all right. So there's a couple ways to deal with this. Actually, my preferred way would just to be to do this. I realize that on the left-hand side, all of these values here are multiplied together. All these are multiplied together. So I am going to kind of go here, do a little rewriting, put my parentheses there, and I say divide both sides by 2 times 3.2. And that is 2 times 3.2. That would imply this is canceled, and I could put this in the calculator just like this. And true, I could rewrite it. I could. If I rewrote it, I would get all of this. I would get 10 times 16 times 2 times 2 times 3.2. We could try it both ways if you don't believe me. It'll all come out in the end, okay? So let's try the first way. I have in parentheses, just so you can see it, okay? 10 times 16 divide by 2, close my parentheses. Now I will divide by, and I'm going to use parentheses again, okay? 2 times 3.2, close my parentheses. Let me look. Make sure that's all there. Okay. Let's use enter 12 and a half. That's actually the option. That's correct. Okay. So putting it in the way we see it didn't hurt anything. Now we could go ahead and do, and I'm going to use some parentheses here too because of that 3.2. Okay. So parentheses 10 times 16, close the parentheses, divide, and open them again. 2 times 2 times 3.2. Close them, push enter, same answer, and we're good to go. Okay, well, that wasn't bad. All right, now let's look at number 6. Okay, yeah. In a given trapezoid, one base is 7 units larger than the other base if the height is 14 units and the area is 315 square units. What is the length of the shorter base? So this is what we got going on here. We know that the area of a trapezoid should be, and I'm going to put over here. The whole thing is going to be equal to 315, right? Okay, so the whole thing is probably ought to go so far there. Okay, so we know that the height is 14 and that we have to divide it by 2. We don't have a choice. However, we have a little conundrum here. 7 units greater than the other base. So let's just call the other base B. And the two bases are added together. Okay, so we have 7 plus the B, that's the first one. That's the larger one. And then we have to add that to just the B, which is the smaller one. So this is really what we got going on here. We have B, 7 plus B, and this is 14. Okay, so what do we have now? So let's rewrite the, well, before we do any rewriting, let's get rid of this 2. So let's say times 2 on both sides. So what's going to happen? Cancel, cancel. Now we can rewrite, okay? So what we really have, to be honest, is we have, and I'll use some parentheses here, 7 times 14. We have to distribute. 7 times 14, okay? Now this is going to kind of throw you for a loop a little. Plus 14 times 2b equals 315 times 2. What did I do? There's 2 b's here. We have 2 of them. So we have, so that isn't helping me. So really we have 14 and 7 plus 2b. Now when I write it like that, you probably see it a little better. Okay, but I just distributed the whole thing. Now, we do have to subtract the 7 times 14 from both sides. So minus 7 times 14, and that means minus 7 times 14. Now let's do some rewriting, and this cancels out, and we have 14 times 2b equals. Now I'm going to put all this in the calculator. Okay. Here. There it is. It's a little messy. So let's deal with that. Okay. So in parentheses, 315 times the 2, close the parentheses, and subtract, more parentheses, 7 times, oh, that's supposed to be 14, not a 4. There, that's better. Okay, and that's 14. Now I close my parentheses, and I enter. Okay, that is 532. Now divide both sides by the 14 times 2. 14 times 2. This is canceled, and this is really what we're looking for right here. And that's exactly what the question asks for. What is the length of the shorter base? And we called that B. So we should be all right. Okay, so I already have 732 there. So let's divide that answer by, in parentheses, 14 times the 2 and close the parentheses. Okay, now enter, and that's 19, which is the correct option. Okay, all right, that is the last question for this video. The second part to the quizzes, starting with number 7, will be up next. And, thank you for watching. I really appreciate the support that I'm getting. It's amazing. I'm glad I'm helping everybody. At least some people are being helped out. And that's great. And keep sharing us, keep liking us so we know how we're doing. And don't forget to subscribe. Happy testing.